Now that we've talked about the capabilities that are provided by Android's concurrency framework, let's dive a little bit more deeply into the class and interface elements of Android's concurrency frameworks. We'll be discussing all of these classes throughout the rest of this lesson. Android's concurrency frameworks are built using reusable classes and interfaces. We're going to focus both on the classes and interfaces used to write concurrent Android programs, in other words, the actual artifacts that you would see as an application developer. And we'll also outline the implementation of Android's concurrency frameworks from an internals perspective, though we won't be spending quite as much time on those topics in this particular lesson. We'll start by talking about the most fundamental element in Android's concurrency frameworks, which is something called the looper. And this is used to run a message loop for a thread. It could be a background thread, or as the case shown in this diagram, it's actually the main thread, also known as the user interface or UI thread. And the user interface thread in Android is always part of what's called the main activity. And as you can see here, this looper runs a loop where it goes ahead and waits on a message queue for the next message to show up. It takes that message off when it arrives, blocking if necessary, and then it goes ahead and it dispatches that message to the appropriate target. And we'll talk more about what the messages look like and the targets look like and the message queue looks like in just a moment. But that's the job of the looper, just to run indefinitely, handling messages that are passed into the thread. The message queue itself is essentially a doubly linked list that holds the list of messages that are to be dispatched by the looper that's associated with that message queue. Messages are never added directly to a message queue, but instead, there's something called a handler object that's associated with the looper, and that's what's used to actually enqueue the messages onto the message queue. And we'll talk a bit more about handlers in just a moment. As we talked about in the previous discussion, the looper blocks on the message queue until the next message in the queue is available. So if there's no messages in the queue, the looper blocks. When the next message shows up, the looper will pull it off and dispatch it. The message itself is a data structure that contains data in the form of fields, as well as type information, in other words, indicating what type of message it is. And a message can be sent to a handler via a message queue. And we'll see in a moment that the handler plays a key role in both getting the message passed into the queue and also to have the message dispatched appropriately in the appropriate thread. The handler is essentially a class that's used to send and process messages and runnables in the message queue that's associated with a thread's looper. And it actually plays two roles. It plays the role of a proxy from the point of view for the calling thread. So the calling thread will send a message via the handler into the message queue. And then the handler also plays the role of a target adapter for having the message dispatched, typically in a different thread of control. So handlers have a very interesting multi-dimensional role in the Android concurrency framework. A runnable, as you undoubtedly know, is a very common Java interface that can be used to represent a command that can be executed, either in the same context or a different context, either the same thread or a different thread. And typically, when it's used with the Android concurrency frameworks, this command, runnable, is often run in a thread that's different than the thread it was created in. And this is what's used to pass commands from one thread to another, using the command processor pattern. All five of these classes are used by both the Hammer and the AsyncTask concurrency frameworks. As we'll see, the Hammer framework exposes some of these classes to the app developers directly, in particular messages, handlers, and runnables in conjunction with threads, whereas the AsyncTask framework shields the application developers from the knowledge of these classes. They hide those details behind the AsyncTask API. There's also some additional classes that are used by the AsyncTask concurrency framework, in particular future task. If you recall, we talked about future task in a previous lesson earlier in the course. And future task can be used to start and cancel a computation that runs asynchronously, typically in a thread from a pool of threads, You can also query a future task to see if a computation is done, which could be used to decide whether or not you want to cancel it. And you can also retrieve the result of the computation when it finishes. And there are various ways to do this, either by using get or by overriding the done hook method that we had talked about earlier. The AsyncTask framework also uses the Executor framework, which we also talked about earlier in the class. And this can be used to execute submitted runnable tasks either sequentially in one thread, which could either run in the foreground or in the background, or it could also run the task concurrently in a pool of threads. And you can actually configure the Executor thread pool that's used by the AsyncTask framework in ways we'll talk about later. These various framework elements are used both by Android's application frameworks as well as its packaged applications. So if you take a look at the application framework layer, you'll see lots of frameworks like the package manager and the activity manager service and the location manager and the notification service and the window manager use these frameworks. And then, of course, many of the applications that come bundled with Android and/or which you might develop or other developers or third parties might develop also use these elements in the Android concurrency frameworks. So that's the end of the discussion of the Android concurrency framework structure and functionality.